Morning, dear students. I welcome you all in the science stream of this new session. Let's start with the first chapter of PT1 syllabus, that is Basic Concepts of Chemistry. Before going in the details of the chapter, I'll want to briefly introduce with the subject chemistry and what does it deal with. So, chemistry, as you all know, is the branch of science that deals with study of composition, properties, and interaction of matter. Matter, what is matter, what it is made up of, how it is interacting with other kind of matter, that all are discussed under this field of science. Next, we come to importance of chemistry in our daily life. As you can see around yourself, there are in every field, chemistry is involved in our life. For example, food. We are having food, all the nutrients, you all know that they are particular chemicals like proteins, carbohydrates, and moreover, to preserve our food for providing a long shelf life, we are adding certain chemicals as antioxidants and preservatives. For increasing crop yield, we are requiring fertilizers, pesticides, and weedicides. They are also given by chemistry. Then, in the field of medicines, there are certain life saving drugs which are recently introduced to the world, and these are actually saving life of people from various diseases like cancer and AIDS. And these medicines, Taxol and cisplatin, are for cancer, and AZT, that is azithromycin, is the drug which is used for AIDS. Next, we come to fuels and energies. So, variety of fuels and energy resources are not other than the chemistry. Next is green chemistry. It's a very important field of chemistry in which there are various methods provided by the scientists to overcome the environmental pollution conditions. Next, if we come to in our daily life, soaps and detergents that we are using in our daily life, nowadays non-biodegradable detergents are also formed recently. They are synthesized in laboratories. Next, we come to the clothing or the daily life articles of plastics and polymers. So, all these fields you are well aware of, and you know that they are important for our life. Next, we start with the first topic of the chapter, that is matter. Matter, as you all know, and you have earlier also studied in your junior classes, that anything in universe that has mass and occupies space and can be felt with any one or more of our five senses is called matter. So all living and non-living beings are made up of matter because we all have mass, we occupy space, and all these things we can feel them. Next, how we can classify matter on the basis of physical states, like physical appearance matter की कैसी होती है उसके बेस पे there are three main states of matter. Firstly, solid state, and as you have also studied in your previous classes that in solids particles are very closely packed and there is hardly any space between them, and particles are strongly held together by intermolecular forces of attraction, and they have very less kinetic energy and they just vibrate on their position. And due to these properties, solids have fixed shape and size, high rigidity, and almost incompressible. Next is the liquids. Liquids have loose packing of particles with large interparticle space, but still the forces in liquid particles are strong enough to bind the particles in the boundaries of the liquid. So liquids do not have fixed shape, but they have fixed volume. Next, we come to the gaseous state. As you can see that particles are very far from each other, means very loose packing of particles is present in gaseous state. Hence, they do not have fixed shape or volume. And particles keep on moving randomly in any direction with a fast movement. That is, they have very high kinetic energy. And that is the reason that gases have very high fluidity and very high compressibility. Next, if we see these three states of matter, liquid, solid and gas, they can be interconvertible into each other. मीन्स हम एक स्टेट को दूसरे स्टेट में कन्वर्ट कर सकते हैं बाय वेरिंग द कंडीशंस ऑफ टेम्परेचर एंड प्रेशर. If you heat a solid, what happens? It just melts to form a liquid. And if you heat a liquid at a particular temperature, then it changes into gas. So we can say each and every state of matter can be interconvertible into each other, and you can have a look at this diagram where solid, when converts into liquid, the process is called fusion. When liquid converts into gas, the process is called boiling or vaporization. When a gas directly converts into a solid, then it is called sublimation. And when a liquid converts into a solid, the process is called freezing or solidification. And when a gas converts into a liquid, then it is called condensation. And this can be carried out by either by heating or cooling, or by applying pressure. As you can see in the picture, then that if we compress gases, first they convert into liquid and then finally they can be converted into solid. So by varying the conditions of temperature and pressure, we can carry out following these interconversions of different matter. Next is the chemical classification of matter. Matter को chemically किस तरह से हम क्लासिफाई कर सकते हैं, तो उसमें सबसे इम्पॉर्टेंट है कि मैटर के जो पार्टिकल्स हैं, इफ द पार्टिकल्स आर of same type, then that type of matter is called a pure substance. And if the matter has different types of particles and these particles are not chemically combined, then the type of matter is called mixture. And as you all have done this in earlier classes, that pure substances are of two types on the basis of type of particles present in them. प्योर सब्सटेंसेस जिनमें सेम टाइप के एटम्स होते हैं, एटम्स अगर सेम टाइप के हैं, देन दैट पर्टिकुलर प्योर सब्सटेंस इज टर्म्ड एज एलिमेंट. फॉर एग्जांपल ऑक्सीजन, हीलियम, आयरन, सोडियम, सबके अलग अलग सैंपल अगर हम कंसिडर करें तो दे विल हैव सेम टाइप ऑफ एटम्स. सो दीज आर कंसिडर्ड टू बी एज एलिमेंट्स. एंड एलिमेंट्स actually are the simplest form of matter that cannot be separated by any chemical or physical process. And the second type of pure substances are the compounds. Compounds are those type of pure substances which have same type of molecules. And these molecules may have different types of atoms as well, but molecules must be same, then that pure substance should be termed as compound. And for example, water, carbon dioxide, sodium chloride, sugar, all these are the compounds in which elements are chemically combined in a fixed ratio of their masses. Next type of matter is a mixture. Mixture may have two or more than two types of substances which are just mixed together, but they do not interact chemically. अगर वो chemically react नहीं करते, हम उन्हें किसी भी ratio में mix कर सकते हैं, then they form a kind of mixture. Mixtures on the basis of composition and properties can be classified into two types: homogeneous mixture and heterogeneous mixtures. Homogeneous mixtures have uniform composition throughout and their properties are also uniform, and these are mainly called solutions. Any type of solution in which solute is thoroughly mixed in the solvent, then it is termed as a homogeneous mixture. And heterogeneous mixtures are those mixtures in which properties and composition आर नॉट यूनिफॉर्म, एक जैसा नहीं. आप अगर एक मिक्सचर का सैंपल अलग अलग जगह से उसके सैंपल लेते हैं और हर जगह पे प्रॉपर्टीज डिफरेंट आ रही है, कॉम्पोजिशन डिफरेंट है, देन दे आर टर्म्ड एज हेट्रोजेनियस मिक्सचर. तो हेट्रोजेनियस मिक्सचर्स कैन बी फर्दर क्लासिफाइड एज colloids and suspension. Next is the main topic of the physical quantities. Like when we study sciences in physics or chemistry, first we need to understand what are the basic physical quantities which are used for measurement. And there are 7 physical quantities internationally selected as the basic or fundamental physical quantities. And the table given shows these 7 basic quantities with their SI units and the symbol used to depict them. First is length. SI unit of length is meter. Symbol used is m. Second physical basic quantity is mass. SI unit kilogram. Symbol used is kg. Third is time. SI unit second. Symbol used is s. And thermodynamic temperature is the fourth basic quantity, and the SI unit Kelvin, symbol K. Amount of substance, mainly in chemistry, if we use some amount of substance, then SI unit for that is mole, and the symbol used is mole. Electric current, SI unit is ampere, and the symbol used is A. And the luminous intensity, the SI unit used is candela, and the symbol is CD. So these are 7 basic physical quantities, and other physical quantities are mainly derived from these quantities. Let us discuss what are those other quantities. First is volume. Volume, as you can say that side multiplied by side multiplied by side, that is length, breadth and height. When they multiply together, then it gives the measure of a volume of a particular object. So as 3 sides are multiplied there, so you can say that SI unit of volume is meter cube. But in chemistry, when we are using liquids, then volume can be given in some other form, which is called as liter or milliliters. And 1 meter cube is equal to 1000 liters, and 1 centimeter cube is equal to 1 milliliter. So you can see from this table. Next is the density. Density is the mass per unit volume, and as you can see the formula of the density, and if you put the units of mass and volume, you can say that the SI unit of density is kilogram per meter cube. But in chemistry, we generally use smaller units. For solids, we use gram per centimeter cube, and for liquid samples, we can use gram per milliliter, or for gaseous samples, we can use gram per liter as well. That we'll discuss in other further chapters. Next is temperature. As you all know that SI unit of temperature is Kelvin, and there are some other units of temperature also, named Celsius and Fahrenheit. So if you want to convert, and when you solve numericals in chemistry, we generally use SI unit, but sometimes the temperature may be given in Celsius scale, so you can easily convert that Celsius temperature by adding 273 to convert into Kelvin scale. And you can use this formula given, and for converting temperature into Fahrenheit from Celsius, you can use the formula 1.8 multiplied by temperature in degrees Celsius plus 32. You will get the answer in Fahrenheit. So these formula you can practice to convert various units of temperature. Next is, actually in SI system, various prefixes are used with these basic units actually. For example, you know that for measuring higher or greater masses, we generally use kilogram, or for smaller units we use gram, milligram. So these prefixes kilo, milli, mega, deca, centi, micro, these are used to depict smaller or larger measurements. And in this table you can see that for the higher units, iota is 10 raised to the power 24, zeta 10 raised to the power 21, exa 10 raised to the power 18, peta 10 raised to the power 15, giga 10 raised to the power 9, mega 10 raised to the power 6, kilo 10 raised to the power 3. That is kilogram or kilometer. Wherever we use kilo with that basic unit, it gives the value in this form, that 1 kilometer is equal to 1000 meter. Hecto 10 raised to the power 2, deca 10. And for smaller units, we can use deci 10 raised to the power minus 1, centi 10 raised to the power minus 2, milli 10 raised to the power minus 3, micro 10 raised to the power minus 6, nano. For example, if it is asked how many meters are there in 1 nanometer, so 1 nanometer is equal to 10 raised to the power minus 9 meters. 1 picometer is equal to 10 raised to the minus 12 meters. So these smaller units are mainly used in chemistry when we discuss the size of atoms and all, because chemistry deals with very small particles. So generally we require these smaller units to depict measurements in chemistry. Thank you. Have a nice day.